Hello there. In this video, I'll be going over CAD, DFM or Design for Manufacturing, and integration of off-the-shelf components into your custom builds. We'll be taking a look at how to get started on a project, sourcing your parts for the project, inputting those parts into CAD, and designing your custom parts around them. Getting started on a project can be quite difficult, especially if it is something that is going to stretch the bounds of your capabilities. But it can be highly rewarding once you follow through, learn new skills, and finally complete the project. I should know, my garage is full of projects, ranging from conceptualized and gathering parts to fully completed. Most of them being in the I started but I'll finish it later stage. Force feedback VR gloves? I started, but I'll continue the project when my 3D printer is rebuilt. The 3D printer rebuild? I didn't necessarily need to tear it completely apart when I was bored the other day, but it's been needing a rebuild for quite some time now, and I need the excuse to use the large supply of 3D printer parts left over from my other 3D printer build for advanced materials. The advanced materials 3D printer build? Let's not fall into that rabbit hole of feature creep. Yes, we'll have an actively heated, fully enclosed build chamber for printing things like nylon and polycarbonate, but do I really need to redesign the print head from air-cooled to water-cooled because it's totally freaking awesome? Well, I already bought the parts and I'm just waiting on my indecisive butt to order the custom machined water block. The point is, for some people, me included, it's easy to start a project, but it's very hard to finish when a shiny new project idea pops into my head. The easiest place to get ideas is to just subscribe to a few YouTube maker creators and amalgamate some of their creations with those little, what if I did it this way thoughts that pop into your head. Sure, I fudged up the steering linkages the first time around, but that's why we tack weld, so we can pull it back apart and try a different approach. The rear end was rebuilt 2 times, and I walked away with the knowledge of why it doesn't work those other ways. It's okay to make mistakes. It's one of the best ways that we can learn, grow, and be confident in what we do. It's okay if your idea doesn't end up working. What matters is that you use creative thinking and a little ingenuity to answer why it doesn't work that way. And it's very likely that you'll eventually figure out something that does work. And you'll bask in the glory as your family members take turns driving around your 1800-watt Power Wheels with the biggest grin on their face. Once you have the project idea and the motivation to set it in action, it's time to be resourceful. What will the components be made out of? Or more importantly, what do you think they can be made out of? Where are you getting your materials? Scrap bins, craft store, Amazon, eBay? Is there a component you can get within means so you don't have to rack your brain over how you're going to make a gearbox in such a way as to not have to replace the 3D printed gears every time you get a little froggy with the accelerator? Let's say you want to build a custom RC car. What do you want it to look like? What features do you want it to have? Do the manufacturers of those cars that you're gaining inspiration from have detailed parts diagrams that you can source further ideas from? Or even just purchase some of the harder wearing or complex components and design around them? Since I am hard on my cars when I drive them, I make sure that some of the key driveline and suspension components are off the shelf, because 3D printed plastic doesn't do so well with shear force, torsion, or impacts. So I looked at the cars with the most readily available components and found that the Traxxas Bandit Wrestler Slash chassis has some parts that I could use. If you don't know if a 3D printed part is going to be strong enough for your application, just model it in CAD, print it, and test it until it breaks. Let's say you bought these really cool shocks on eBay and you want to make sure they fit in your model so that the suspension travel aligns with the stroke of the shock. What we can do is take some measurements while it's right in front of us and rebuild the model in CAD. If you want to have motion and movement with your parts, make sure the moving halves are different part files in SOLIDWORKS, or different bodies in Fusion 360. I primarily use SOLIDWORKS, so if you want to learn how or just brush up on different techniques, let me know and I can make a video or do a live stream to answer some questions live while modeling. If you want me to show you Fusion 360, I can do that as well. Just let me know. You can make your models as simple or complex as you want. Since I'm not making these off-the-shelf components from the ground up, I don't need to model every facet of them. Just the parts that matter, like hole sizes, shaft lengths, any body thicknesses for clearing the other components. Just sit back and enjoy some footage of me modeling up in SOLIDWORKS. Once your parts are all modeled up, now it's time to import the part files into your main assembly and give them relations and constraints towards each other and other parts. If we compare the new and the old shocks and take some measurements from eye hole to eye hole, we can see that there's kind of a disparity. The new shocks are about 100 to 105 millimeters in length, and the old ones are about 110. Now we get to open up our 3D printable part and alter it to accept the new part geometry. When that is all complete, we will go back to the assembly and cycle through the full range of motion and alter any other 3D printed parts so we don't have any binding or collisions. If you're wondering about my color schema, generally I like to use different colors for different materials. So for the white, that's going to be PETG, for the gray, that's going to be TPU, and I usually reserve PLA for blue. But wait, something doesn't seem quite right. Let me measure the parts again. Oh, that's why. It seems I modeled the rear shock and put it on the front of the car in the assembly, but there's no biggie. That's what our parametric modeling practice can help us with. All I have to do is make copies of the ones I modeled and alter them for the smaller geometry. You can do this in your configuration manager, but I find less of a headache by making and altering copies. Don't worry, I'll be right back after some quick modeling. Okay, I may have gotten a little carried away with modeling off camera. Here's a view of the chassis before, and now after. Pay attention to the yellow parts, I'll show it again. Before, now after. You can really see how much shorter the shock towers are with the shorter shocks. I went with these ones because I decided to get a stadium truck body, which didn't look quite right with the super high shocks. but now the body will sit 20 to 25 millimeters lower. Now, I want to briefly go over DFM, or Design for Manufacturing. DFM is when you design your parts for manufacturing in a specific way, ensuring that the design is optimized for that manufacturing method. Here are some things you should consider when designing for 3D printing. Do your layer lines fall across a structure that may be subject to lateral load? These shock towers were designed to be 3D printed laying down like you see here. We do this so we don't put any more load across the weakest part of the print, being the layer lines. Does your part have steep overhangs? You can totally have steep overhangs, meaning 55 degrees or more, but you'll have to use supports in order to get the geometry you're after. But supports waste material, time in printing, and leave a surface finish that is not so good. It is best to just design around not having them at all. This steering knuckle needs to have 90-degree overhangs, but it's a small part, so it's not too bad. One of the last things I want to touch on is part selection and purchasing. This gearbox here was purchased new from eBay. There are actually a lot of sellers parting out ready-to-run cars and making pretty good money off the parts. The reason I decided to go with this one was because if I purchased all the parts individually from Traxxas, it would have been nearly double of what I paid for this parted out transmission off eBay. So I think I talked your ear off long enough for now, but this is my main takeaway. If you have an idea, just build it. If you don't know where to start, do a little keyword research. If you're still stuck, reach out to your fellow makers. We're always here to help and build upon our collective knowledge together. And don't get discouraged because someone else did something before you. Just know that great minds think alike. And feel free to reach out. Thanks for watching and take care.